us, but that feedback is very valuable to us. It's extremely valuable. And so whether you can catch Astrid or me sometime this morning or shoot us an email a couple of weeks from now, we'll both be going on vacation sometime over the next couple of weeks. So think about sending us an email sometime in August. But, you know, let us know what it is that you liked about the meeting. Let us know what it is we can do to continue to improve upon it. But just very pleased with how this has come together and how it's flowed. And certainly feel like that, you know, it's been another great meeting for the association, for your association. So with that, another one of our friends who falls within the category that needs no introduction, a very limited introduction, is our friend Brandon Nuttall from the Kentucky Geological Survey. Before we have Brandon come up, KOGA and the membership should extend a deep appreciation to Brandon for his volunteer services that he provides at all of our meetings, but also just, you know, continues to be engaged and continues to be a resource for us throughout the year. But certainly appreciate everything that Brandon does. Certainly everyone's looking forward to the presentation that Brandon is about ready to give. And so without further ado, I'll just turn it over to our friend Brandon Nuttall.
Well, gee, I'm kind of embarrassed after that glowing introduction, because I know there's a bunch of people out there that know a whole lot more about what I'm going to be talking about than I do, because they've been driving up and down the roads, they've been watching the drone videos, and all I've got is what's publicly available, okay? So anyway, I'm going to be talking about three things, so I'm not going to be talking in detail about any of them. I'm going to be talking about the New Albany, a little bit about the Berea and the Rogersville, and what's going on in these. I like to call them, you know, they're emerging plays. They're very exciting things that are going on here in Kentucky. I do have to acknowledge that I'm only a small part of a large team of people at the Kentucky Geological Survey in our Energy and Minerals section. I'd particularly like to recognize Dave Harris. I don't know if you remember, there used to be, I think it was an insurance commercial, I'm not sure, where they were herding cats. Well, we're the cats, and Dave is the guy that keeps us all in line. But all of us are working at the university, at the Kentucky Geological Survey, to help make information available to you. And I must admit, it's not in my talk, but Tuesday, the Utica Playbook was released. And so if you're interested in the Utica, there is a website where you can actually download the entire playbook, all its maps. The website, there is a little flyer on the KGS booth that you'll find that. So I'm going to start. Kentucky, of course, is underlain by gas shales. We have it both in the eastern Kentucky, the Ohio Shale, western Kentucky, the New Albany Shale. And that's basically where a lot of what's going on, even though it's older production in many cases, a lot of exciting things are going on. So if we start with the New Albany Shale, where this has got really interesting is that in 2011, several wells were drilled. The completion reports were submitted indicating they were gas wells. But a year later, completion reports, new reports were submitted indicating these wells were oil wells. They'd been converted to oil wells. And this was real interesting for a couple of reasons, one of which was we actually had some core through the New Albany that had been studying in the Bland well in Hancock County, and we were able to get samples of oils, samples of the New Albany Shale from one of the Endeavor wells, and we've been able to do some work on it. The production, it differs a little bit from the typical New Albany Shale type completions in western Kentucky. Most of the time they were vertical wells and they were completed throughout the entire interval of the shale. But the Endeavor wells, like this one, the number 5, was completed in a high gamma ray, low density zone right at the top of the shale. This is the top of what's called the Grassy Creek member. And it also turns out, interestingly enough, and I'm working on getting some geochemical data to confirm it, but there have been a few One of these is a laser pointer on here somewhere. Well, it doesn't matter. Right at the top, that little sandy zone at the top has sometimes been charged and is serving as a reservoir and has been completed, and we're trying to understand that too. So if we look, there's no particular reason structurally why the oil should be there in that western part of, there it is, in that western part of Breckinridge County. We're talking about, here's the Rough Creek fault zone. This is the Locust Hill Cave Springs fault zone, and the Breckinridge County stuff is right in here. And you can see we're just basically on a nice uniform monocline. So there's no structural reason really why that oil should be there. The interesting thing is that all of the information that we have available says that the shale in this area is immature. It's early mature, type 1 and type 2, oil-prone marine source rock. There is some data from several publications, and you'll see it plotted here, and it's all crowded over here with the oxygen index very low, indicating that it is pretty low maturity. When you map out the vitrinite reflectance, you can clearly see the area in the central part of the Illinois Basin. That area has generated most of the hydrocarbons that have been produced in the Illinois Basin. But we're looking at stuff that's way over here on the margins of the basin, immature. And so the idea is, what can we do to understand this? In terms of activity, there have been 51 permits issued in the area since 2013. We have been receiving completion reports on a bunch of them. Some of the wells are pretty good, 36 barrels a day, 50 MCF of gas per day. Some of the newer completions, 45 barrels of oil per day. Now the ones with the X's through them right there, those were wells that are producing the same oil, but as far as we know, they're producing from that little silty zone that sits right on top of the New Albany Shale rather than the actual shale itself. The star of these new wells, however, is one that has produced since 2013. Now that's 2013 is the latest available public oil and gas production data, so it may have produced more, but in 2013, in about 8 months, I believe, that well produced over 5,000 barrels. So this is a really interesting liquids play that we don't know a lot about. And what we've done is there is, if anybody remembers the old Defense Advanced Research Projects Agency, well, ARPA has expanded. They now have an energy section, and we're putting together a proposal to look at the role of catalytic hydrocarbon generation in these low maturity reservoirs to see if we can understand why is there oil in the New Albany in that area. Once we understand that, we may be able to project additional places to go look for it. Now, everybody is really interested in the Rogersville, and this is where the drones are, things like that. And the Rogersville is really interesting for several reasons, because since the 1920s, people have been drilling deep wells in eastern Kentucky looking for additional resources. But until a few years ago, 2012 roughly, 2013, they were all looking for conventional reservoirs. And in the conventional reservoir side, in the 90s, we had the Homer field that was discovered. And the production there, we didn't know where the oil came from. And so a research project was started, a consortium looked at it, and we found that we were able to identify a source rock. If we look at the setting of Homer, this is just a generalized cross-section. Here, everything is thin and shallow north of the Kentucky River Fault Zone. You cross the Kentucky River Fault Zone and you have the setting on what's called the Irvin Paint Creek Shelf for the Homer field. You cross into the deepest part of the Rome Trough, and what you end up with is a very thick section of Cambrian Conasauga, and it's got this organic rich Rogersville shale in it. And testing the well, the Exxon Smith well in West Virginia of that core showed that that was indeed the source for what was in the Homer field. Well, since that report was published in 2007, everybody's now looking, wait a minute, the shales themselves can be reservoirs. We've got the technology. And so they're targeting that. The information has been released. This is just a type log of that area showing the Rogersville shale interval in here, this organic rich shale that was the source rock. It is an alternating shale with thin silty zones in it. It's anywhere from 5,000 to 10,000 feet deep in eastern Kentucky, and that's kind of the reservoir that everybody is targeting. Where is it? Well, that's a good question. This map is mostly a lot of debate and speculation, but the idea is that while the Rogersville actually is present over a much larger area, in fact, it's named for its outcrop in Tennessee near the town of Rogersville, we think the prospective area of Rogersville production is indicated here by this hashed pattern of lines. And you can see here are where the publicly known wells are, the wells that we have an idea about. I believe that one's the Bruin, the one on the top there is the Bruin well. But this data right now that we've got in this map is essentially based on 2004 data. And so we're eagerly awaiting the data release for the Bruin well sometime in mid-August. We'll get that, and depending upon exactly what they release, if we get one sheet of paper for the completion report, it'll take about 15 minutes to release the data. If we get a stack of logs, it might take us a couple of days to get those all scanned and available on the web. There we go. Most of you know these wells. The Bruin well, the data will be released in August. We know the Walbridge well is another Cimarex well. That well has been permitted. The Cabot well in West Virginia has been drilled, and the rumors are that it is a very good well. We do know that the horizontal technology well over in Johnson County, that has been drilled and it's been fracked. But all we know is that there was an awful lot of equipment on that particular lease at that time. We have other strat tests that have been permitted. It will be a while before we figure out what those are, where they are. But again, you guys with the drones probably already know that. I'm going to finish up with the Berea, because the Berea really is an exciting story in eastern Kentucky. It is a sandy, silty, alternating sandy, silty zone between the Ohio Shale, one of our main gas producers, and the Sunbury Shale in eastern Kentucky. And you can see it here in the outcrop. You can see how it varies and why geosteering is very important to be able to stay within the Berea. The Berea is one of our oldest reservoirs. The first producer was drilled in 1879 near Paintsville. There was a boom in the 1890s in Lawrence County. In 1905, it was designated as a minor producer compared to several other things, shows of oil and gas, but this led in the 20s to a drilling boom. The 1980s were big for the Berea. When the Section 29 tax credit came into effect, the tight formation credit, in fact, the Kentucky Oil and Gas Association sponsored the East Kentucky Tight Gas Committee of the Kentucky Oil and Gas Association. John Avila was in charge of that committee. I don't know how many people here still remember John Avila, but we did a lot of studying on the Berea and how tight it was, but that was a big boom for that area. But in 2011, they began drilling horizontal wells, these shallow horizontal wells, and using smaller slickwater fracs. And you'll notice if we look at statewide production, the big thing is that 58% of the oil in 2014 is coming from eastern Kentucky, and this big increase here is all eastern Kentucky, and it's almost every drop of that Berea. mostly from Lawrence and Greenup County. And to show you the effect, the reason for that is if we look at the horizontal wells that were drilled, most of these wells in the red are gas wells. These were wells, a lot of them drilled by EQT in southeastern Kentucky. But these slick water fracs in the Berea are the ones that have really brought about this renaissance in Berea production. If we look at where they are, most of them are in parts of Lawrence, these old fields in Lawrence County, going up into the Greenup County area. They're almost all of them are producing oil. There are some that are strictly gas. But what this has done is Lawrence County is now the #1 oil producing county in the state of Kentucky. Greenup is not far behind. And if we look at the traditional Union and Henderson counties, they've been traditionally for decades the leading producing counties in the state. Most of that production is enhanced oil recovery. Most of it is water floods. So they've been online for a long time. This is all primary production right here. So that's really exciting. And if we look at where the horizontal wells are that have public production data, this gives us some interesting insight into some of what's going on. If we look at that production data, we have some that's oddly behaved. This one turns out to be 2 wells completed at 2 different times that have been added together. I inquired about that. We have some operational difficulties. I'm not quite sure exactly what's going on with that. We do have some that's well behaved, and when we look at the well behaved ones, I want to point out that there's a special quantity that I'm going to be using. That's the maximum rate of production for an individual well. Whatever that monthly production rate is, it's the maximum rate for that well. I'm going to focus in on that. When I focus in on it, I find that that maximum monthly rate ranges from about 323 barrels, which is better than 10 barrels a day, all the way up to nearly 8,000 barrels in that month. The median, 1,074. So these are good wells that are being produced. And if we look at the ones that have production data, I'm using that maximum monthly rate of production to put them all on a similar scale, dimensionless monthly production rate, and then I slide them all over so that they all start at that month and decline from there. We have 30 wells that have at least 6 months of production, and if we look at that, what I do is I'm taking each period of production, the first, second, third period of production, and finding the median for that. This is pretty noisy data. It's early time data. And I make a composite decline curve. And when I analyze that decline curve, it shows that these things are a basic decline rate, over time of about, in the first year, of about 60% or so. The B up here is a special exponent. It tells me that this is a low permeability reservoir. So you're going to have to frack it to get anything out. And again, that's being very successful. So Koga asked some questions a couple of years ago about what the average well in Kentucky is producing. And I looked at the 2010 data, and I found that 99% of Kentucky's wells produce less than 10 barrels of oil per day. They are stripper wells, okay? 99%, 10 barrels of oil per day or less. But if I look at the publicly available production data I've got for the Berea, 92% of those produce more than 10 barrels of oil per day, okay? And in fact, the median well is producing nearly 26 barrels of oil per day. 50% of the Berea wells are averaging over 26 barrels of oil per day. So those are good wells. Where are they? Well, if we look at those average daily oil rates on a barrels of oil equivalent basis, I can make little circles up here that show what proportion is oil, what proportion is gas. And if we look at the Greenup County wells, we can see that a lot of the Greenup County wells are producing about half and half on a BTU basis. Those are the wells up here in Greenup County. The Lawrence County wells, I don't have quite as much production data. Not as many wells have been reported. This is actually, that's a weird looking number because that's 2 wells. It's 2 well heads, the surface locations of 2 different directed horizontal legs. And so they plot one on top of the other and the numbers get crowded. This is the biggest one of the Berea wells, and you can see that it has produced over 29,000 barrels of oil for the production that we've got available in terms of barrels of oil equivalents. So the Kentucky Geological Survey has a consortium to look at trying to develop an understanding of the distribution and preservation of the oil and gas in the Berea. Help figure out what's going on and how does that relate to production. The biggest research question, the big goal is to try to understand what controls the Berea production, where it is, and again, we've got that weird, odd thing going on. It's thermally immature. It should not have that oil in it. It should not be, but it's there. And so by classic theory, we don't know what's going on. We have consortium partners, and I'd like to thank many of you are in this room today listening. So I probably haven't told you a whole lot that you don't know. But Marty Parrish, Steve Grebb, and Cortland Ebel are working on this, and we will have a report coming out in a couple of years. I think we're only about halfway through the project. So in conclusion, we've got the Devonian New Albany Shale, and it's an immature shale that does produce liquids. The Berea, we've got additional potential across much of Kentucky. We know it's productive in more areas than Lawrence and Greenup County. It's just we're not quite sure we understand it. The Rogersville, it's speculative. Limited data suggests that it's got good potential, but we're all waiting, just like you, for the actual well data to be released to the public. And in many cases, it all depends on the price of oil and gas, how exciting these are actually going to be in the next couple of years. Thank you.
Any questions out there? Yep, Rudy.
Brandon, thinking about Berea oil and sourced, you've given up the idea that it's the Ohio Shale or anything like that, is that, and the reason I'm asking this question is because we've had some analysis done on our Weir wells, trying to figure out if that was sourced from right around the Weir sands. Doesn't seem to be, according to the people out west that are supposed to be a lot smarter than that. So where's it coming from?
We haven't given up on that. The most likely source is the Ohio Shale, but the Ohio, if you look at the maturity of the shale, especially in those areas, the maturity doesn't match the oil generation. So it's the same problem that we've got in the New Albany and the Illinois Basin. Why is the shale generating oil when it's immature? The Berea above the Ohio Shale, that Cleveland, that organic rich zone right at the top of the shale, is most likely the source. I don't have the samples and I don't have the funding yet, but one of the things we're trying to do at the New Albany is we're trying to match core geochemistry to oil geochemistry. And eventually, if we could do that in the Ohio Shale and the Berea in eastern Kentucky, I'm fairly confident that the Ohio Shale would be the source. But again, you have the situation where the Ohio Shale is a relative, not only is it low maturity, it's also low pressure. So oil generated in that is not going to migrate very far, and the Berea is a logical place for it to go.
And the Weir right above it. We'll figure it out.
Well, fund us a consortium. Yes, sir.
We had Tommy Kate first. Yep.
Brandon, based on your type curve, what sort of EUR are you projecting?
I'm not.
Oh, come on. You got the curve.
No, you'll notice that I cut that curve off at the data that I had available. And so, being as I am a university employee on the payroll of the state, I'm going to avoid making economic decisions.
My first undergraduate research project was that same road cut on the AA highway, and we found the ripple marks
Oh, yeah.
in that, and I saw the concretions. Are there some other weird features, so to speak?
You've got lots of slumps. You've got channels. It's a whole sedimentology course just in the Berea in terms of deposition. So yeah, and we're looking at all of that and the role that has on the heterogeneity of the reservoir itself.
Okay.
Steve Grebb is the lead on doing the sedimentology. So. Okay.
Any other questions out there? All right, thank you, Brandon.
Thank you.